Hello and welcome to today's rather impromptu episode of Rawkode Live. Today we're going to be taking a look at Kubernetes services, breaking it down and trying to understand how they work, how to use them, and anything else that pops up. Today I'm joined by Anaïs and Philipp. Hello, how are you both?
Hello, great, thank you.
So in a moment,
I'm great too. Thanks for having me.
Yeah, no, my pleasure, honestly. Let's just quickly I'll have you both do a quick introduction, and then we'll talk about why we're here, what we want to cover, and then we'll just get straight into it and see what happens. So, Anaïs, would you like to go first?
Awesome. Yeah, sure. So I guess also kind of the story of how it came to this episode in some way. I've just recently transitioned into DevOps. I've worked for the past years in the blockchain industry, mainly doing community management and developer relations. And then found out about CodeFresh, which is a CI/CD platform, and joined CodeFresh mid of October. And since then, I've embarked on this learning journey across DevOps and specifically learning everything that I can about Kubernetes. So I've made it my mission, so to say, to put everything that I'm learning live on a public Notion page where you can read my notes and everything that I come across and any resources that I found particularly useful. So I've just started end of last year a challenge called 100 Days of Kubernetes, where I aim to learn every day something new about Kubernetes. And I've realized in the past days, so to say, that I don't quite understand enough about services and specifically ports within Kubernetes resources. And so that's what this episode is going to be more about. Yeah.
Awesome, thank you. Philipp?
Yeah, so I'm Philipp. I ended up on this live stream mostly because I saw a tweet and offered to answer some questions. I've been in cloud and containers and Kubernetes for quite a long time. It's more like 10 years than 100 days. I started a PaaS company in 2009, and I'm currently spending my days working on an open source Terraform framework that helps people do GitOps with Terraform for Kubernetes, basically. And yeah, well, I'm excited to see what the questions are going to be and if we can figure it out together.
Fingers crossed. I'm sure between us we'll get through this for sure. All right.
Yes,
so,
we will. I'm pretty
yeah, I mean, I'm confident. I mean, although it's one of those things, the more you use Kubernetes, I think the more things you learn that you just don't understand were there. But
that becomes more natural.
Exactly. All right, so why don't we start with, was there any YAML and specifically that you were working with, Anaïs, that you would like us to use and go through to try and break down? Or do you want me just to throw something together really quickly and we can talk about the different components as we kind of go?
Yeah, so I was just using like a really basic React application and kind of deploying the container on my cluster and getting up and running through a deployment, and then started from there to integrate like services with it on the cluster. So it's really basic YAML. The main problem was basically that there are lots of resources, but there are little resources that go in detail of like the different components that make up that YAML file. So yeah, feel free to throw something together. That might be interesting.
Well, yeah, let's see if I can remember how to YAML. But what I'll do is throw together two Nginx services. So we'll call this Nginx 1. And I know the state bar is really difficult to read, but hopefully the code here should be better. So we have a deployment. We'll call this Nginx 1. And we'll deploy Nginx. I'll just let this yell at me, and Nginx runs on port 80. So this is what I would just call a really standard deployment. And we'll have two. So let's do, too much. And what we want to do is, I'm assuming when you were working through the YAML that you were working with, is you want two services or two deployments or pods to be able to communicate with each other over the Kubernetes control plane.
Yeah, that as well. And also, I mean, starting like really simple, just how would you access starting from like the beginning? How would you create a NodePort and access your application, your running application? If it's like one step back.
I don't think that's actually a step back. I would probably start from inside out, right? So I think it's better to first understand what a pod does and how the communication between multiple containers inside a pod would work. And then we can go, how can two pods talk to each other? And then we can go to the point of how do we deploy a bunch of pods from a deployment, right? Because that's, again, it's another abstraction layer on top already. So I don't know how I don't know how to start this. Should we just like look at the pod for a starting point?
So
Or is this too...
there was quite a lot in what you mentioned there. So let's so yeah, what you said there is we could talk about the networking model with multiple containers in a single pod without ever reaching the networking stack across the services first, right?
Mhm.
That's your suggestion. Okay. So let's modify our first pod spec then. I'll add a second container. We'll deploy it to the cluster, and then we can talk about what is actually happening here. So we'll call this nginx 1.2 and nginx 1.1. And that won't actually work, will it? Because the ports will try to bind on the same interface. So let's deploy something else.
In this case?
Yes, please.
In this case, how do you know that the container port is 80? Is it by default?
I'm just really
Nginx?
familiar with Nginx, and I know that it runs on port 80, as does HTTPD. You know, this is like the standard non-TLS HTTP port. And maybe Philip can explain this slightly better than I can now. So if you run multiple containers in a single pod, they share the same namespace and networking space, which means that we cannot have two Nginxes running on port 80. I believe, and we can confirm that just now actually, that if I try to deploy this, it will fail. Is that right, Philip?
Yes, that's pretty right. So I think basically the way I look at this, and I'm no expert in networking at all, I'm just help myself by, having like a bridge to understand this. So basically, I'm looking at a pod as a computer, right? It has one network interface, has one IP address, and so it shares the port namespace, right? So any port inside this one computer can only be used once. Of course, that isn't true because you can have virtual interfaces, and then each virtual interface has its own set of ports, right? But for this specific example, it's just a pod has one of those pod IPs, right? And so any container you start inside shares the number of available ports. So you cannot use them twice. And if they want to talk to each other within that pod, they can talk to each other. So one container talking to another container inside the same pod, they can talk to each other localhost and that port that you are listening on. And so if you start Nginx twice, you would have to have one of them listen on a different port.
Exactly, and we've just confirmed that. We can actually see here that our Nginx 2 pod is relatively happy here, but our Nginx 1 pod does keep erroring, and that's because it cannot rebind that port number. So that means we have to, if we want to show how the networking works within a single pod, we need to run something else that doesn't listen on port 80. Any quick suggestions of an image that's I can throw in here?
I'm not super familiar with the Nginx image, but it probably has an environment variable that you can tell it to use different port, no?
Probably. I just don't know what it is.
Yeah, we would have to check out with the images documentation.
I'll just throw in MariaDB10. I think that's the right tag.
Okay.
It runs on the MySQL port, which is going to be... I can't even remember, but it's not port 80. So let's put this in. We run our watch again. This should get healthy. That's the old one that errored, so I'm not worried about that. And the second one just hasn't come up yet, so we'll give that a moment. Yeah, we had a... Oh no, I've broken that one too. Oh yeah, MySQL. Oh. I'm failing miserably. So we had some good comments as well there at the same time. Let me see. So Costas said 3C06 is the port. You are correct. And also use Redis. Yeah, that might have been easier. The reason the MariaDB/MySQL one just failed there is that it actually can't run without some environment variables. So that was a very terrible choice in image by myself. Does Redis need environment variables?
Also, like a bit of an anti-pattern, right? You shouldn't run your Nginx and your database in the same pod. That's a bit of a
Cut me some slack, Philip. This is a demo. This isn't. I'm not shipping it to
Yeah,
production.
I
I
know.
promise.
But we should probably mention this to the viewers so they don't, tune out because we're complete morons.
Yeah,
And
someone's
conclude
just
they
tuned in
have
right
no
there
idea
and
what
went, "They're
they're
doing what? No, it's closed." So, yeah, I wouldn't recommend that pattern. You're correct. Yeah, Redis, I think, is happy without any environment variable. So you can see now that this has worked. So let's talk about what actually happened there. If we describe pod 1.7, which is our new one with Redis, we can see that we have 2 containers here running in a single pod. And what happens there is that they share the same networking space, they share the same port allocations, they can communicate over localhost. Is there anything we need to be able to add there? Does that even make sense to everyone, what I've just said? Yes, okay.
I think it makes
Yeah, it does make sense.
if Nginx in this case, right, was a web application we had written and not like this web server only, we could now talk to our Redis with localhost in whatever the Redis port is.
Yeah.
But if we wanted this process if the Nginx process was not Nginx but our own web application, we can now talk to Redis by connecting to localhost and the Redis port.
Yeah. And the benefits of that are that it doesn't go over your traditional kernel TCP networking stack, right? It's typically faster. There's no security risks, at least less security risks. Is that a fair comment?
If you do this, you're basically talking localhost, right? Those 2 processes will end up on the same node. So it's the same localhost connection that you would have on if you were to do this on your single computer. If you had put those 2 containers into different pods, they may end up being scheduled to different nodes. And then you would actually have increased latency as a first step because you might actually end up talking through a real network on different machines. And that adds latency, right? So for web applications, there sometimes is a use case where you would do something like this because you want your cache to be very, very fast, right? And you put them right next to the actual process that uses the cache can, in certain applications, have benefits. It's kind of hard to say with this example.
And in this example, let's say they would be in both containers would be in different pods, but they would be running in the same node. For instance, if I have only one node and I can be certain about that, they would not be able to communicate through localhost, or they would be?
They would not.
They would not be.
If they are in different pods, each pod has its own IP address, and if you want to speak between pods,
then they would have to know
then you have to go
the
IP network for communication.
Okay.
Okay, so that covers networking within a pod using localhost. The only thing you really need to be aware of is port collisions. If you navigate that, there are use cases for using multiple containers in the same port. The same pod, this is generally what we call the sidecar pattern in Kubernetes land, where we want to be able to add extra functionality to our applications without modifying our own code, kind of.
Yeah.
All right, so let's get back to then Anaïs' original question was networking across pods and namespaces and all of our Kubernetes clusters and using services. Now, there are 3 different types of services, if I remember correctly. Do we want to discuss what each of those are and the use cases for each?
I think one thing I would like to point out before we go there is the service doesn't actually do the networking, right? Any pod can talk to any other pod. The difficulty is just you don't know its IP address. So services are primarily for service discovery. They help you how to find out who to talk to, right?
Yeah, that's correct. The service concept or primitive within Kubernetes provides a means for service discovery, which is a pretty much a solved problem when you adopt Kubernetes, and load balancing across the pod within that service.
Right, depending on what service type you choose, then you also would get, for example, load balancing, because the service has its service IP address. It announces the service IP address in DNS. And so when you try to talk to this service, you can talk to a DNS name. It resolves to the service's IP address. And the service has endpoints, which are all the pods that it can find via its selector labels. And this is how it can end up talking to these various pods.
Okay.
So that's like a big.
That was a nice
overview from the
explanation.
start. Let's probably dig in a little bit to make this more understandable for everybody.
I think it would be useful, like for this demonstration, to focus on the difference between ClusterIP and NodePort. Unless we want to, I mean,
No, that makes sense. So
that would be my
ClusterIP
understanding.
ClusterIP is the default service type, so we'll get one of those running. And NodePort has got some very specific use cases. I guess it's actually 4 service type. The third one would be a load balancer type, which is only supported in some environments, and the fourth one would be a headless service, which actually handles traffic in a slightly unique way. But we're going to disregard those two and focus on ClusterIP and NodePort and try and break that down for you. So let's expose.
Well, there's also there's NodePort and HostPort if you want to make it really complicated, and then there is also I forgot the name, but there's a service type which does nothing but add an entry to the DNS, to the internal Kubernetes DNS. I think it's called external DNS or something like this.
The external name services.
Yeah, it's a service type external or something, external DNS, something like this, or external name.
I don't know if
have
it's
to look this up.
Yeah, I don't think it's. The semantics aren't important, but you're right. Yeah, there is the ability to bring in external services and expose them as a Kubernetes service. Okay, so let's make a service available for our first deployment here, which has this label.
Can the name be anything? Like in this case, when you named a service?
It could be anything that is a DNS compatible name. So you can't use dots, but you can use alphanumeric and dashes.
And it doesn't have to be connected in this case with the deployment. It just
so it's connected to something called a selector, which is based on the labels. So you can see here what I'm telling that. I mean, services are relatively simple as a definition. All we're saying here is we want to make something available with this name, Nginx1, and it's going to find any target which has a label called app with the value Nginx1. And we could...
Yeah, so I think the question, you're free to name the service anything you like, as long as it is according to the Kubernetes naming convention, right? But it probably makes sense to call it something that's related to your deployment, so you keep track of which two things belong together. If your deployment is called dog and the service is called cat, that may not be the best idea.
Exactly. Yeah, I think it's always valuable to remember that Kubernetes is a computer and will do whatever is told. That humans are usually working with this, and we want to make it as simple as possible. So yeah, standard naming conventions do make a lot of sense. But I'm going to go against that now because I've already renamed it to Anaïs1. So let's go with that. All right. Now we can get away with very little bit of config here and rely a lot on the defaults. So I'm just going to apply this. We'll see what we get, and we'll try and understand what's actually happened here. So I've not set a service type in the spec. All I've done is configure the selector and tell it the port that we want the service to be available on. This is probably on you go.
Yeah. No, I wanted to drill more on the container port versus port. On how is that the port that's the service, and then the service forwards that to the container port, and the container port could be something different, or do they have to, like, what is the relation between those two ports, or they don't have any relation?
Yeah. So the port will be the port number that the service IP is available on. You can then have that point to a different port within the container if you need. So like if you have an application that listens on a random port and you want to expose it over a standard port, then you can configure that correctly. And then NodePort brings in another variable to the mix as well that we'll cover when we do other node ports. I think that's right. Let's apply. So now if we run kubecontrol get services, you'll see here we have the Anaïs1 service that we created, and it now gets a cluster IP because that's the default service type. And we can ignore external IP for now, and it's exposed on the port that we told it to be available on, which just so happens to be the same port that Nginx is listening on, but that is mostly irrelevant right now. Another really valuable command when working with services in Kubernetes is to describe it. And what you're looking for here every time is this endpoints. More often than not, if your service isn't working within the cluster, it's because it has no endpoints. And the number one reason, at least in my experience here, is if there are no endpoints on a service, you have your selector wrong. Meaning I cannot fetch any pods with that selector. A good way to confirm that that also works is to use a label selector when you do get pods. So we can run this command here, and if that returns pods, then your endpoint is configured correctly.
The endpoint in this case is the endpoint of the container, like that refers to the pod that the containers run in, or?
So when we apply the service to the cluster will grab that selector, it will look up all of the pods, and if they're ready and available, they will be added to the endpoints list, which just means that they're available to handle any requests to that service IP address.
By default, it will just add all of them, but you have the readiness check to determine if it's actually ready, right? So if you configure a readiness check in your pod, this is how you can control at what point your application is ready to be added as an endpoint. Or, because the readiness check will run continuously along the lifetime of the pod, it would also remove it from the endpoints if at some point in the future your readiness check turns false again. Right, so
the readiness check runs automatically, or that's something that will also be defined in the YAML in that case?
No, in the pod you have the ability to configure two health checks, the readiness check and the liveness probe, and the readiness one determines if it's inside the endpoints, if it's included in load balancing basically, and the other one determines if it's going to be restarted according to whatever rules you put in there.
And in that case, like if I don't define the values, they are by default defined to certain numbers, to certain values, or?
No, if you don't define it, then it's just included in the endpoints immediately as soon as Kubernetes has started the container. And then it doesn't basically determine if the process inside the container has had time to come up. For example, Java applications can take quite a bit of time to boot up in a lot of cases, right?
Yeah, a couple of
weeks. So you may actually end up sending traffic to this process already before the process is ready to answer.
Yeah.
Yeah. I maybe it makes sense to go into liveness and readiness probes. Maybe we can do that after a little bit of the service stuff. Unless you want to dive into it, then let me know. But yeah, everything Philipp said there is 100% correct. Like if these exist, you can define when your application is actually handling traffic correctly or is ready to handle traffic, and the services can add and remove them as needed to make sure that you're not delivering broken Nginxes to your customers and such. So yeah, great information. Okay, so we have 2 deployments, some pods, and a service that allows us to now communicate. So I guess, what do you think we should cover next? Will we talk about the DNS conventions for service discovery?
Yeah, one thing about the selector, we mentioned that you have to set the selector, and if you don't get it right, then you usually end up having no endpoints and it doesn't work. Should we mention how you get it right? What labels you actually have to set where in order for the selector to find your pods?
It's more extensive.
I found this super confusing because there's metadata labels everywhere. And I was like, do I put the metadata labels in the deployment? Or do they have to be under deployment spec, template spec metadata labels?
That's one of my biggest frustrations with the the selectors on a deployment is this. There's some replication, and I don't understand why it's maybe not automated. But yeah, do you want to break that down then, Philipp?
No, it was a question. I'm not claiming I know everything.
All right, so hold on, let me get a comment on. So Costas has said, yeah, we should have a whole episode on liveness and readiness probes. I think you're right. There is a lot there. So maybe that's something I'll get scheduled soon. All right, so
very cool.
yeah, when you define a deployment, and much the same way that a service works out which pods or endpoints to load balance traffic over, a deployment has to understand, I don't want to go too deep in this because it's a bit of a segue, the deployment has to work out which replica sets are under its control, and then the replica sets have to work out which pods are under its control, and it's just labels all the way down. So what we have here in the deployment selector is, say, all of the replicate sets which have a label of app and the value of Nginx are under our control. And then we have a template on the pod spec, which also adds labels of app and Nginx to each of the pods. And it's just like labels and all of these different resources that group them all together in some like homogeneous fashion to be queried against the control plane. If I got anything wrong there, feel free to jump in and fix it.
And in that case, you as a complete newbie looking at that, you would wonder at the beginning, why can't you use the name for that if as a form of label? Do you have to define the name, or what happens if I don't define the name, then a random name is set? And
the labels have the benefit that you could have multiple of those, and you can query for a combination also, right? So there's some rules you could say. You can have like an app Nginx1 like we have now, and you could have another label, for example, for an environment, for staging or prod, and then you could make sure that the staging service will only ever include staging pods by also querying for the environment. Okay,
that
so
makes
that
sense.
would be one way. It's there's also more advanced use for this, but I think what's important here is the reason why we can set those templates here inside the deployment spec is only because the deployment is a higher level abstraction already.
Yep.
And it has some things it does to the resources that it controls, replica sets and pods eventually, right? But if we were to use a naked pod, which you almost never do unless you want to understand this, then you would have to set the labels on the pod itself for the service to find it.
Yeah, I mean, I try to avoid talking about replica sets as much as possible. As people are learning Kubernetes, I don't think there's a lot of value initially to understand what their role is. So maybe that's a rabbit hole.
I actually have I have a recruiting. If you apply for a job and I end up recruiting you, I'll ask about this quite a lot, because I think it's important to understand how these things work together. Because if it breaks and you have to figure out why, it's better to know. Like, my question is usually, how does a rolling update work? What happens inside the Kubernetes control plane when you change the image tag of your deployment? What does it do?
I do think that is important, but as someone
important.
on their first month of Kubernetes, does that make a lot of sense to break it down? I don't know. Let's say we're conflicted on that one. Where do you want to go next, Anaïs? This was your question, and I don't want us to get bogged down by details and random things. I want to make sure
I think this is great. To be honest, there's also aspects that I wouldn't think about it in a more complex manner, like replica sets. For me, it's just like, oh, I want to have two of the same thing. I just use a replica set kind of style, right? So I guess it's something you also discover through using it, of the specifics of how they work and what might go wrong or not. But what would be cool to maybe go into more detail is actually a lot of examples when you look at basic deployment resources, is they show multiple port naming. They have target port, container port, and then also when you introduce NodePort, they have NodePort, they have a NodePort, right? And I think that's then when I'm not too sure if people also who have been using it over time know the exact connection, or it's just something that people know and they don't really write about it. So that might be interesting to go into more detail.
So the service has, I think services are a little bit overloaded, right? They have multiple use cases. We already talked about the ClusterIP ones, which gives you another IP address inside your cluster, basically, you can talk to. A way to find this IP address via DNS. And then also the load balancing, whenever you talk to this cluster IP address, it will forward the traffic to one of the pods that's behind it via this endpoint mechanic that we just discussed, right? But other service types may actually do something quite different. For example, the NodePort you mentioned, basically what NodePort does is, instead of reserving an IP address, I think it reserves an IP address too, but that's out of the point here, is it also sets up a kubeproxy to start listening on the host, the worker, on that specific port. And so now you can talk to the host's IP address. And then in case of I sometimes get this wrong, and correct me, maybe chat will correct me if I'm wrong, but basically there's NodePort and HostPort. NodePort would set up proxy on any node in the cluster, independently if the pod is running on that node or not, to listen on this port that you specify, and set up IP tables magic, so that when you talk to any node IP address and that port, the traffic will end up at your pod. Okay? And HostPort does something similar, except it only does this on the node that does actually have your pod running. Does that make sense? This saves you a hop, basically.
Let's show this by example. I think that's going to make sense. So what I'm going to do is, firstly, we're going to update this to be something more useful. So instead of MariaDB, what we're actually going to use is something from the OpenFAS project called NodeInfo, which I should call the right thing. Because this is going to expose, as we request the HTTP server on that container, it's going to return information about the pod that answered the request, and that's going to show us the load balancing. We'll expose that as a ClusterIP, and I'm also going to expose it as a NodePort, and then we will take a look at how that actually functions, and hopefully that answers a lot of the questions that we have. So we need to expose the port, and it runs on 8080, I believe, so we should be okay running that side by side with Nginx. That's already exposed as, oh, it's not. Nginx is exposed as Anaïs 1. And we'll also have Anaïs NodeInfo as another service. Going to have the same selector running on a different port. And finally, we'll do this again, only this time we'll add a type of NodePort, same selector, and we'll expose the node info. And well, I'm not going to set any other fields right now. I'm just going to leave that as is. We'll take a look at what is created. We'll hopefully be able to explain it and show how it works.
I think what we'll probably have to look at is when do you use one or the other, right? They have different use cases, and I think that's what really matters in the end.
I mean, in my opinion, that's a really, really simple question to answer. So I'm going to throw out my simple approach and let you shoot that down. But the only time you should ever use a NodePort service is if you want to expose something outside of your cluster. And it's not the best way to do it. It's a kind of a hacky, quick way to do it because you don't have any ingress controlled or configured for your cluster. So yeah, NodePort is only there if you want to hacky, quick expose this to the wild or the internet kind of thing. Would you agree with that?
Yeah, I would agree with that. Yeah, no. If you want to expose something outside of the cluster, the first thing you should look into is ingress, right? However, there may be some edge cases where you have to go down to a lower level, and then those NodePort, HostPort services are useful. If you ever end up setting up, for example, Nginx ingress, if you deploy your own ingress, then you will eventually have to touch on this, right? Because you need a way to somehow get the traffic to the Nginx ingress controller in the first place. And that's
Nice.
also where this HostPort, NodePort difference comes into play.
So just clarifying in the YAML resource that you defined, in those services where you didn't say NodePort, it's by default ClusterIP?
That is correct. If you omit it, the default by the Kubernetes control plane or the defaulters is to set this to ClusterIP.
Okay. And the ports, you just out of simplicity reason named them and the service the same as in the deployment?
Yeah, so let's run over that again quickly then. So the first cluster IP I have matched the name with the deployment that we want to expose, and the selectors also match up. This is the ideal approach, right? Generally, everything lines up, everything's the same. If anything differs, you can spot it right away from the YAML. You understand what's going on. Something else that's important to note from all of these definitions, that I've only ever configured port, and the only port that is important is the one in the container that I want to expose over the service. You can get away 9 times out of 10 without ever tweaking that, and you'll be okay. The next one we have is the NodeInfo service. So the selector is the same in that I want this deployment. Oops, excuse me. I still want to target this deployment, but I'm exposing a different port number, so I've just named the service to be slightly different. So it's okay here, but obviously looking at it at first glance, I'd go, oh, something's a little different about this. And then finally, the node... Sorry, and you go, Philip?
could you expose both of them in the same service? Which is a trick
You
question.
can expose multiple ports in the same service, yes. I
And
guess
in this case, we could, because they're inside the same pod. Right, so if you look at the first one, we could have both of them exposed there. And because they're in the same pod, this works. But if they were in a different pods, then the selectors would be different, and then we couldn't do this. And then we would need to use two services.
yes, you're correct. And right, yeah, we should show that as well. Okay, and then the last one is a NodePort. So we have a special name for that. We're using the same selector, and again, we're just targeting the one that we want to expose. So this NodePort is the exact same, only instead of a cluster IP, it's going to, well, you still get a cluster IP, I think, but it's going to also expose a high port number that is available on any node within your cluster, and it will use the kube proxy to route that to a pod regardless of the node it is on. And we won't see that working, but we can try and explain it. Just because this is a local cluster, there is only one node. Okay, so let me reapply this so we get the changes. Oh yeah. When you expose multiple ports like this, you do need to provide a name to give it some form of uniqueness.
Do you need, in that case, both, if they have different labels, both labels? Or how would it know which one to?
So when you call the service IP, you can specify a port number, and I believe it will route you to the right one. We'll confirm that, actually. I think I've maybe just confused myself there. Okay, so let's take a look at our service definitions. So we have our first one, which is here. The Anaïs 1 cluster IP, we have an IP address, and we can see that 2 ports are available, and we can query either one. So we can query on port 80 default and get the Nginx service. We can hit 8080 and we'll get the node info service. We have our node info one, which is the same as the first one, but a separate definition. And then we have our NodePort one here. So you can see we still get the cluster IP, so we can still reference it within the cluster. But we can also see here with this colon that we have this high port number of 30,202, which actually means I can query from outside of the cluster on any node IP on that port number, and it will route me to one of the pods in that service.
Can you try it out?
Yes, I can. I was going to say that's a lot of words. Let's just actually finally show it working. And I know there's lots of comments coming in. Let me get back to that in a second once we've actually shown something here. So let's jump inside one of these pods. Let's get pods exec into Nginx 2 because we haven't exposed this at all yet. And hopefully I've got bash. Yeah, okay. Do I have curl? Yes. So we could use the cluster IPs for all of this, but one of the nice things about Kubernetes is that we get DNS-based discovery, which means we can actually use the service name within the namespace with very little configuration. So what that means is I can just query Anaïs 1, and you'll see I get the Nginx response. I can also change the port, and I get the node info response. Okay. Now I want to change one more thing here to show the load balancing as well. So I'm going to modify the replicas on this deployment here. Let's just run 4. And then we'll go back in here. So we can hit that on port 80 as many times as we want, and we get Nginx. We can hit it as many times as we want on port 8080. And you'll see the last part of the tuple, the naming convention here, is the pod ID, and you can see we had load balanced across 2 different pods there when we requested that service name. Does that make sense? We understand what's going on there. Okay. So
I think one question was also about port and target port. Maybe we should talk about this also a little bit.
Yes. Let me demo the node port, then we'll tackle the target port as well then.
Okay.
And we're going to do so let's run get nodes. Oh, wait, did I get an IP address? Yes. Okay, so this is my IP address of my node. I think Docker for Mac is going to let me query that. We're about to find out. And I'm going to target on 30,202, which is that node port. So this is me outside of the cluster. This is me on my local machine. Of course, that doesn't work, so that was the thing. Docker for Mac does provide a DNS name. I have no idea if that's the right one. I should have used Linux. Anyone know how Docker for Mac works?
Is there a way to SSH into the virtual machine that it starts for you?
No, you cannot SSH into the virtual machine. There is a DNS name though. In fact, let's just use the docs, right? I mean, I don't know everything. I Google stuff more than I actually know stuff. So, Docker for Mac, DNS name, NodePort. Let's see what the internet says.
Well, I also don't know any of this. kubectl explain all the time in the background here.
Yeah, exactly. There is a DNS name for Docker for Mac that allows you to Docker for Mac.localhost. Maybe I was close. Docker for Mac did actually resolve in the Docker for Mac. Okay, let's try that IP address. I don't think the NodePort works then with Docker for Mac, so I can't show you that. And I don't know if I have any clusters available. However, that would work. Trust me, right? I'm a very trustable person. The NodePort just means this. I think what happens is the CNI implementation or kubeproxy, whatever one it is, configures an IP table on all of the nodes that says, listen on this port number, the 30,202, and when the request comes in, it will forward it to some pod on your cluster somewhere. Unfortunately, I don't think I can show you it working. Which leads us on to Philipp's thing now. Target ports. You want to... What one would you like to change, Philipp?
Well, I think we should actually change the second one, because we have the second one we listen on 8080 in the actual process, right?
Yes.
Which is beneficial because we would rather want to have all our pods listen on high-level ports because it doesn't require root or fancy capability magic, right? There's like a whole discussion if unprivileged processes should be able to require low-level ports, but by default on Linux they cannot. So anything that's not root, started by root, cannot bind to any port that's below 1024, if I'm not mistaken. And so we would need to run our web server as root in order to bind to port 80, which is usually not encouraged. It's actually discouraged. I think that's the word. The benefit here is that we can use a service and have the service's port be 80, but have the target port be 8080. And this way we can still talk to our process by talking to some IP on port 80. But in the background, it's actually running under and listening on port 8080 and can be run as an unprivileged user then.
Yes. So let me try and surmise that in one line then. The reason we would use target port is when we want our service to be available on more traditional or privileged port numbers. Like we probably always want our web services available on 443 or 80. However, the container port or the pod doesn't expose the service on that port. The chances are your pod is going to be using something higher like 8080 or 3000 or 4000 or 3306, etc. And instead, what we do is we say, make our service available on 80. However, the pod is going to be listening on 8080. Now, we can now reapply this. And if we exec back into this pod, we can do curl. And the service name here was Anaïs node info. We hit on port 80, so that's just a default web port. It's being forwarded to the pod on port 8080 using the target port definition, and then gives us our response. So that's when you would use target port, is when you want to do a little bit of juggling to get privileged port numbers available on the service that aren't available on your pod.
Okay, in that case, the target port has to match the pod port.
Yes, and then that's when container port comes in, and you can juggle things even more if you really, really, really want to. So I think you mentioned this at the start.
Yeah.
When you're configuring your ports here, is that you can actually expose this. I think it's just port. Is my autocomplete wrong, or am I wrong? Okay, maybe it is host port. Correct me, Philip. What have I got wrong there? I thought you could specify container port and expose it as a different port here, but maybe I'm completely wrong.
I think the most useful part of this is you
This is
can
the host
name
port.
them and
Name
then
them.
address them with the name. You don't have to, you
Oh
can
yeah,
give
of
it a
course.
name here, say name something, web, for example. Then when you reference it from somewhere else, you can reference it as the name.
Yeah, that's a good point as well, actually. So you can
What
see.
is the benefit of that?
You don't have to remember the port number that you put the process.
Yeah, so
But
here.
it refers to the same, right? It refers, to the
Yeah,
name
so
port number.
if we add a name web here and a name node info here, that means in our service definition, instead of referencing this, can you put web there, or is it just named like that? No. I thought you could name it.
No, here you
Oh
can
no,
name
no,
them
that's
too.
yeah. I'm sorry. I'm being really silly. Yeah, this is the pod. This is the port we expose it on, and then the name is the one that is looking up.
Well, I think what you can do here with the name is Kubernetes will set environment variables automatically inside the process's runtime environment that expose certain information about service discovery. The two ways how you can use Kubernetes service discovery is DNS and those environment variables. And based on these names, it will have these environment variables that tell you how to find that thing. Right? It will be something like I don't quote me on this, but it's something like
There.
oh yeah, you can see them there. Right? So it's the service name port 443, and if you give them a name, then it will probably show up there with that name also.
All right, we had a comment from Noel who said, try NodePort on localhost. So just, why not, eh? Docker for Mac makes it easier than even I thought it was supposed to be. So you can see Docker for Mac does actually handle the NodePort on my local networking. So there you go, NodePort does work. Thank you, Noel. Okay, let's see. Did we get any?
I think this is a very special case because that's like, there's networking magic many times now at this point already when you do this on Mac and on localhost. I think what's important to remember is this: if you have actual, for example, you start cloud VMs and you were to start Kubernetes by hand using kubeadm, right, those VMs will probably have an IP address and minus security groups or something like this from the cloud provider, you could talk to those IP addresses, right? And if you say NodePort, some port, you can talk to this IP address under this port from outside the cluster, and the traffic will end up in your container. Right? Because now that you can do localhost and this port is just another layer of networking magic to somehow go from his local networking stack on the Mac into this Linux virtual machine and then inside there eventually to the container.
Yes, lots of magic going on, especially with Docker for Mac. All right, so we're kind of approaching the end of the time that I have available, at least here. So I want to just check back and make sure we actually explained more things than raising more questions. I hope that services are a little bit more comprehensible now. And if you have any final questions, let's try and tackle them.
I think that was great. Like more of a hands-on example than what you would get in the documentation, where it's kind of explained from one perspective on what the different components are. Are there any questions from the comments, maybe, or anything?
Yeah, so we do have a few comments, and not particularly questions, just mostly people telling me that I'm wrong, which I love. So Costa says, thank you for host port. You didn't know about that. He's going to look it up. We also have another comment from Costas who says that developers should or would use ingress or load balancer services most of the time. Yeah, you're right. I mean, I would discourage node ports as much as possible. They're a temporary solution for clusters that don't have a proper ingress route yet. But they're hacky
I would
and
also
available.
discourage load balancer. Load balancer is an edge case also. It's a leftover from previous days.
Yes.
Ingress is the new way, and it should always be the default. You said this, and I totally agree with this. And the default for services should be ClusterIP. You should use services by default to expose a number of pods together within your cluster, so you can talk to them more easily. You can find them. and you can talk to them with a load balancing. If you want to expose outside of the cluster, the default should always be ingress. And then if you have a very specific use case, there are some other more technical things that you then can look into, like load balancer, like NodePort, HostPort, all those other things.
Then we have another comment from Andreas, which I'm going to try and shorten a little bit. But when I complained that I didn't know why we had to have the selector different from the template spec selectors or labels within the deployment spec, apparently it didn't used to be enforced. So now if I were to try and apply that to the cluster and they were different, I would complain. But that's just a legacy thing that's kind of hung around, unfortunately. And to say another comment from Noel, just saying remembrance of the past. Yep, so that's all covered. And that's all our comments. I think we are all good. So I'll just say thank you both for joining me. Thank you for your questions.
Well, thank you.
Anaïs. Thank you, Philipp, for bringing all of that knowledge and helping us. And I hope we didn't raise more questions than we answered. So
it's great. Thank you.
All right. Have a great day. Thank you again. And I'll speak to you both soon. Have a nice day.
Thank you, everyone. Bye-bye.